In this last section, we're going to take a look at hypothesis testing problems involving independent sampling and specifically what makes that different than working with paired sampling like we saw in section 7.2. So looking at our example, we've got the weights of diamonds are measured in carats. The difference between the size of a 0.99 carat diamond and a 1 carat diamond is undetectable to the naked eye, but we would like to perform a hypothesis test to determine if the average price of a 1 carat diamond is higher than the average price of a 0.99 carat diamond. So in these types of problems, we're still going to have two populations. In this case, our two populations are the 1 carat diamonds and the 0.99 carat diamonds. So we've got these two different groups. However, if I wanted to look at the relationship between these two groups, there is no link between the 1 carat diamonds and the 0.99 carat diamonds. If I were to pick out a 1 carat diamond at random, there's nothing that says, oh, that has a specific relationship between this 0.99 carat diamond. There is no such link, which means that we're working with independent sampling. I'm going to write that down. So this is an example of independent sampling, meaning that the two samples are unrelated. There's no relationship between the two of them, at least none that we're aware of. So when we talk about these hypothesis testing problems, it's important that we understand what is our parameter and what's our point estimate. Remember, our parameter is a piece of information about our population. This is what we're testing, what we kind of want to know here. So in this problem, we're looking at the average price of a 1 carat diamond and the average price of a 0.99 carat diamond. And we're going to be looking at the difference here. So if I wanted to write this out in words, my parameter here would be the average price, the difference in average price between a 1 carat diamond and 0.99 carat diamonds. So this is what we're looking at. Just to kind of have one single number, we're going to be looking at the difference once again between these two average values. Now, this is obviously kind of wordy. It's not very nice to work with within formulas. So in this case, we're going to be looking at the population means. We're going to be looking at the difference between our two population means. So in general, the parameter that we're going to be looking at is the average difference between population 1 and population 2. So it's always mu sub 1 minus mu sub 2 is going to be our parameter. This is the thing that we know about our population. So we're looking at the average between population 1 and the average between population 2, and then we're going to subtract those two values. For our specific purposes, I never really like to use 1 and 2 within a problem because I like to keep track of which one corresponds to which population, and that can be difficult to do here. So I might say we're going to call mu sub 1, we'll use that for the 1 carat diamond, and the difference between the average price of a 0.99 carat diamond. So I'm using the subscript 1 for the 1 carat diamonds up here, and I'm using my subscript 0.99 for the average price of a 0.99 carat diamond. That's how I'm going to keep track of them throughout this problem. So there's my parameter for this problem. The point estimate then just says, okay, well, knowing the actual population averages or the difference between these population averages is very, very difficult. So when we talk about a point estimate, this is information from our sample that we're going to use as kind of a proxy or an approximation for the population information. So in this case, instead of using the population mean, our point estimate that is going to be, instead of the population mean, we're just going to use sample mean instead. So we would say x bar sub 1 minus x bar sub 2 in general terms. However, for this problem, since we are working with two different populations, we probably want to keep track of them. I'm going to use, again, x bar 1 for the sample of the 1 carat diamonds, minus x bar sub 0.99 for the sample mean of the 0.99 carat diamonds. And again, just to kind of really reiterate what we're doing here, remember we're using information about our sample, about our point estimate, to make a prediction or an educated guess about what's going on with our population. That's the whole point of hypothesis testing. So we've got our parameter and our point estimate. This should look pretty similar to what we saw when we were working with paired data. We were working with differences back then as well. One thing that we are going to see different here, though, is a difference in the null and alternative hypothesis. So just like before in every other hypothesis testing problem that we've looked at, we're going to talk about H0 and we're going to talk about HA. The thing that makes this different, you could structure these hypotheses the same way that we did with our our paired sampling, but I like to do it a little bit different just to create some separation and help us recognize that this process is in fact going to look a little bit different. We are going to handle these problems a little bit differently when we're working with independent sampling than with paired sampling. And I actually think that these null and alternative hypotheses are actually a little bit easier. So when we're working with independent sampling, again, the null hypothesis we always sort of get for free. We're going to assume that the two population means are equal. So we're going to assume that the difference, in other words, is really equal to 0. But how we can write that is we can say the average price of the 1 carat diamonds is exactly the same as the average price of the 0.99 carat diamonds. So when we set up our null and alternative hypothesis, it's always going to look like here population mean 1 is equal to population mean 2. Those two things are just always going to be equal. So if you can recognize again that we're working with independent sampling, we're going to get these null and alternative hypotheses basically for free. So then the alternative hypothesis, that is going to depend on the language or the claim that's being made in the problem. So we said we want to determine if the average price of a 1 carat diamond is higher than the average price of a 0.99 carat diamond. So here we're going to talk about the population average price of the 1 carat diamonds and the population average price of the 0.99 carat diamonds. And what we want to say is this price point for the 1 carat diamonds, is that average price higher? Meaning, is that value greater than that value? So is it greater than the average price of the 0.99 carat diamonds? So in this case, we're doing a one-tailed test. We're saying mu sub 1 is greater than mu sub 0.99. I tend to think that the alternative hypothesis in particular for independent sampling is easier to set up because we don't have to worry about the differences. It's a little bit easier just to say, well, I think this one's bigger, so it's going to be mu sub 1 is greater than mu sub 0.99. So there is our null hypothesis, and there is our alternative hypothesis. We should be ready to continue on with the rest of this problem now.